Okay, Assalamualaikum and hi. So in this video, we are going to look at the characteristic of image. In our previous video, I have taught you how to sketch the ray diagram in order to see the formation of image. Okay, so based on that formation of image, you can deduce the characteristic of image. Okay, so we can classify the characteristic of image into three parts. The first one is whether the image you have formed is either real or virtual. Okay, it can be either one sahaja. Kalau dia dah real, it can never be virtual. Kalau dia virtual, it can never be real. Okay, so this is the first classification that we will use to characterize the image. The second classification adalah whether the image that we have formed is upright or inverted. Okay, it's either the image that we have formed is upright or inverted. Upright maksudnya it is in the same criteria as the image, as the object. If it's inverted, maksudnya it is opposite to whatever our object looks like. And then the third classification dekat sini adalah whether the image formed is either magnified, much bigger than the object, or it is diminished, much smaller than the diminished. Okay, so these are the three classification we will use to describe the characteristic of image. Okay, when we sketch the ray diagram, we can automatically identify these two characteristics such as the upright, inverted, or magnified or diminished. Ini adalah dua karakteristik yang sangat visible. Bila kita sketch, kita tengok dan kita boleh tahu. Kalau upright, image yang kita akan dapat berbentuk arrow dia ke atas lah. Kalau inverted, arrow dia akan ke bawah. Ataupun dalam kata nama lain, you will have your principal axis in your sketching. Okay, dalam ray diagram kita akan ada principal axis. Ini cermin contoh. Okay, let's say we have concave mirror lah kan. Okay, so if your object is located here and when you sketch your ray diagram, kita akan dapat image begini. Okay, image yang ini. Okay, image yang kita dapat ini is formed below the principal axis. Okay, dia berada below the principal axis, maka kita panggil dia inverted. Okay, sebenarnya kita tengok arrow ni, kita dah tahu this arrow is inverted compared to the object. Okay, however, kalaulah kita dapat image of form something like this, ini image kita, okay, berada above the principal axis, ataupun kalau kita tengok, kita dah tahu dia adalah upright, sama sahaja macam kita punya object. Okay, so for your upright and inverted, kita tengok pada arrow kita ataupun kita tengok pada principal axis. Di atas principal axis upright, below principal axis inverted. Whereas untuk magnified dan juga diminish, kita tengok pada ketinggian objek dan juga image kita. This is your object height. Okay, and this is your image height. Kalaulah image kita, bila kita when you form the image, your image looks much more smaller than the object, maka kita panggil dia diminish, lebih kecil. Magnified, kita cakap bila lebih besar, the image is bigger than the object, maka kita panggil dia magnified. Okay, so however for the real and virtual ini, it depends on where your reflected ray are and also your image is being formed. Okay, so bila kita ada cermin, ini cermin kita akan ada incident ray pergi dan kita akan ada ray being reflected back daripada mirror. When the ray is reflected back from the mirror, this is the reflected ray. Okay, yang hijau ni adalah reflected ray kita. Okay, so your reflected ray is always from the mirror reflecting back. Okay, daripada mirror reflecting back. So untuk kita tentukan image kita real ataupun virtual, kita kena compare your reflected ray ini dengan jarak image yang kita dapat ataupun kedudukan image kita. Okay, so your image untuk first case ini, where you have your image being formed in this particular distance from the image, from the mirror. Ini adalah yang pertama yang kita nak kaji. Okay, for this case, image kita dan reflected ray are on the same side. So, kalau same side, V and reflected ray same side, kita cakap dia adalah real image. Okay, the image yang kita form dekat sini, kita panggil dia real image because the reflected ray and the image are on the same side. However, if your image is formed dekat sini, image ada dekat sini, reflected ray kita berada di hadapan cermin, they are on the opposite sides of the mirror, maka ini adalah virtual image. So this image here is a virtual image. Kenapa? Sebab V dan juga reflected ray kita are on opposite side, therefore virtual image. So they are virtual image dekat sini. Okay, so this is how you deduce the characteristic, either dia real ataupun virtual. Okay, next we are going to look at mirror equation. Mirror equation is given as 1 over f is equals to 1 over u plus 1 over v, where we know f is the focal length, iaitu jarak daripada focus point to the position of your mirror ataupun pole kamu tu lah. And then u is the object distance, where your object is located to the mirror surface, and v pula adalah image distance, where your image is formed from the mirror. Okay, so to use this equation, untuk guna equation focal length, object distance dan juga image distance ini, kita kena consider sign convention. Okay, sign convention dekat sini, kalaulah objek kita adalah real object, kita punya sign convention adalah positif. Kalaulah objek kita adalah virtual object, sign convention kita adalah negatif. Okay, macam mana kita nak tahu objek kita real ataupun virtual? How do we want to know our object is real or virtual? Kita tengok pada DNC method. Okay, for DNC method, the object, untuk objek if the incident ray and light source are in the same side, then the object is real. Okay, so objek kita, object distance ni akan jadi positif. Okay, so selalu cahaya akan berada in front of the mirror lah. Cahaya akan ada in front of the mirror, and as you can see, the incident ray and the light source are on the same side, maka U kita becomes positive. Begitu juga untuk convex mirror, this is the front of the mirror, so kita akan ada light source, and this is your incident ray. Incident ray akan datang daripada mana objek duduk. Objek duduk sini, so dia akan pergi limpas cermin, so this is your incident ray. Therefore, your object here is positive, dia real object. However, if the light source dan juga incident ray kita berada in the opposite direction, maka it is a virtual object, negative. Dalam silibus kita jaranglah kita guna virtual object. However, there is virtual object when the object is in the opposite sides of the light source. That is when kita akan ada virtual object lah kan. Next, begitu juga untuk image kita pun. Image kita can either be real ataupun virtual. If it's a real image, dia adalah positive sign. So to substitute the value here, you have to consider the positive sign here. And then, kalaulah dia virtual, maka kita kena substitute the value with a negative sign here. How do we know dia adalah positif ataupun negatif, iaitu real ataupun virtual? We are going to use the DNC method, draw and compare method. Okay, for the image pula dekat sini, for the image, okay, untuk tahu image kita real ataupun virtual, you have to look where your image is formed, ataupun you have to compare your image dengan your reflected ray. Okey, bila kita ada objek dekat sini, objek akan ada incident ray. Lepas dia bertemu dengan cahaya, kita akan ada reflected ray yang patah balik daripada cermin. So this is your reflected ray. Your reflected ray is going back from where it comes. Okay, for the first case here, kita ada image being formed in front here, in front of the mirror. Kita ada image being formed here. Okay, and as you can see, your image is at this particular distance from the mirror. Ini adalah V kita. Your image and your reflected ray are on the same side. Okay, your reflected ray and your V are on the same side, maka dia adalah real image. However, bila kita ada objek, kita ada mirror, incident ray datang, and then dia akan reflected kembali dari arah yang sama, you're going to form your image. Image yang kita ada berada pada jarak V daripada mirror. This V here now is in the opposite side as your reflected ray, iaitu dia berada on the opposite side. Ini depan cermin, ini belakang cermin. So dia opposite side of the reflected ray. Sebab dia opposite side, maka V kita sekarang, your V is opposite to the reflected ray, maka dia adalah virtual image. So V kita akan jadi negative dekat sini. And as you can see, it is labelled here negative juga, sebab kita punya V dan juga reflected ray opposite side. So that is how you deduce whether your V is positive ataupun negative, dengan kita tentukan dia real atau virtual. And then finally, F dekat sini, focal length kamu pun can be either real ataupun virtual. Tetapi selalunya kita tak guna term real atau virtual, kita guna term converging ataupun diverging. Okey, macam mana kita nak tengok converging ataupun diverging adalah kita akan tengok pada kedudukan focal point itu. Converging is always positive, diverging is always negative. Okey, so your focus point for concave mirror is always in front of the mirror, and for your convex mirror is always behind the mirror. Okay, so kita tengok focus point kita dengan reflected ray kita berada pada arah yang sama atau bertentangan. When they are for concave mirror, the focus point is in front of the mirror and the reflected ray is also in front of the mirror. Mereka berada pada same side. So bila same side, dia adalah positif. Okay, bila same side dia adalah positif dekat sini, maka ini adalah dia membawa maksud dia adalah converging. Ataupun dalam kata nama lain, you can also look at how the ray diagram is formed. For a concave mirror, the ray, reflected ray is always converging towards the focus point. Maka dia adalah converging mirror. Bila converging mirror, the focus point is positive. Untuk kita punya convex mirror pula, convex mirror, the focus point is behind the mirror and the reflected ray is in front the mirror. So they are in the opposite side, maka mereka negatif dekat sini. So your focal length is negative. Another method here adalah kita tengok untuk convex mirror, bila kita ada reflected ray dia sentiasa diverging from the focus point. So bila dia diverging from the focus point, dia membawa maksud dia adalah mirror jenis diverging here. So when it is a diverging mirror, dia akan ada sifat negatif dekat sini. So the sign convention for focal length becomes negative when it is a diverging mirror, iaitu convex mirror. Okay, last but not least, we are going to look at the magnification. Magnification dekat sini is the ratio of the height of the image to the height of the object, iaitu tinggi image dibahagi dengan tinggi objek. Okay, from this magnification, kita akan dapat ratio of the heights where you can get a certain value. Value yang kita dapat ini can interpret 3 benda. Okay, iaitu if the ratio of the height is equals to 1, this indicates the magnification here ataupun the image here is the same size as the object. Kalaulah the ratio gives you a value greater than 1, maksudnya kita punya image kita magnified. Image kita lebih besar daripada objek. However, if you get your M less than 1, kita dapat M less than 1, maksudnya image kita mengecil. It is a diminished here. Okay. However, this equation M is equals to H over H naught is also can be written as magnification sama dengan negative V over U, where image distance divided by the object distance. To use this equation, kita kena consider this sign convention dekat sini. Kalaulah objek kita real, positif, virtual, negatif. Begitu juga image real, positif, virtual, negatif. So for this part, you have to consider the sign convention. Okay, so when you do calculation here, disebabkan equation kita memang ada negatif, and then let's say your image is a real image, virtual image, contoh virtual image, so kita akan ada negative value here divided by real object, kita akan dapat a positive magnification dekat sini. Okay, positive magnification indicates that this positive here indicates the image is upright. Okay, however, kalaulah bila kita guna equation ini, kita punya image dekat sini adalah real image dan juga objek dekat sini adalah real objek. Dua-dua real image pun real, objek pun real, kita akan dapat negative magnification here. Negative here indicates the image is inverted. Okay. So, daripada magnification ini, we can deduce two characteristic. One is by the sign here, positive atau negative. Another one is by the value of the magnification itself. Okay. Kalaulah kita dapat dekat sini positif 1/3. Okay. Positif ini indicate image kita upright. And then image kita magnified. Diminished. Kenapa? Sebab dia diminish sebab image kita mempunyai nilai 1/3 magnification saja, which is less than 1. Maka dia diminish. Okay, let's say kita dapat negative 3 pula. If you get negative 3 here, this indicates that your image is inverted, sebab negative sign here indicate inverted, and the value 3 here refer kepada magnified. Dia bukan negative 3 as in dia mempunyai negative value bukan Negative dekat sini adalah sign to indicate whether your image is inverted ataupun upright. Value here dekat sini to indicate dia diminish ataupun magnified. Sebab dia negative, maka dia inverted. 3 maksudnya dia lebih besar daripada 1, magnified. Okay, so when you use this equation, iaitu the definition of the magnification, ratio of the height, you can only determine whether dia same size, magnified ataupun diminished. Tapi if you were to use this equation, kita boleh dapat dua karakteristik, whether dia upright ataupun inverted, iaitu melihat pada sign dia positif atau negatif, and then tengok pada nilai dia, whether dia magnified ataupun diminished. So, for your M here, menggunakan equation dekat atas ni, you will have two parts of the answer. Positive, negative dan juga value. Positive, negative indicate upright ataupun inverted. Value here indicate magnified ataupun diminished.